Hello, everyone. I'm truly grateful that you chose to come to my talk. I promise I'll make it worth it. This talk is about a hacking technique, an easy one and powerful, from which you can get remote code execution on EC2 instances. My name is Eduard Gavriloae. I'm a proud associate manager at KPMG Romania. We were the ones roaming around these days with purple hoodies. I'm also a co-founder of infosec.ro. My focus is on cloud security. You can find me on Twitter at SawyerPacket, and I also write articles along with my colleagues on securitycafe.ro. I wanted to ask you something. How many of you did get a remote code execution in the last year? Okay, and who got 2 remote code executions? Okay, and who got 3? Okay, I hope my manager saw who raised the hand and will ask for a CV. For me, in 2.5 years, I got 1 remote code execution on something that was not cloud related. However, only in the last year, abusing cloud misconfigurations, I got 3 remote code executions, but they are like nothing you've seen before. Some vulnerabilities that will compromise the entire EC2 instances from an AWS account. And this raises a question. Why try to attack web applications, which are hard, and remote code execution is rarely encountered nowadays on web applications, when you can choose a path of less resistance and focusing on cloud misconfigurations? And the feature that we will abuse is a built-in feature from AWS, and it has some differences between a classical web vulnerability that will give you remote code execution, but through a web shell, you need to do prevesc, you might be blocked by a web firewall, whereas this feature called SSM run command will give you root, will give you full reverse shells, and no instance from the AWS account is safe. So, the feature, run command from Instance Manager, also called SSM, is the highlighted feature from the bottom left. It has some cool qualities for hackers. So basically, it's a built-in remote code execution machine. But everything is executed as root, and you don't need to have network connectivity to the instance. I think this is the dream of every red teamer, right? But it's also the nightmare of every defender. And we'll see more about this in our demo. Just a quick overview of how it works. The most important part is that we are using this document, which is just a JSON file that is interpreted on the instance, and we give it a command using this parameter, right? In this case, I gave the command ID. In return, we get an ID, and with that ID, we then get the output of our command. And as you can see, it was executed as root without doing anything additional. Now, this feature can also be used to run commands on multiple EC2 instances at once. And imagine this scenario where you send the same command either to exfiltrate credentials or to get reverse shells from multiple EC2 instances at once in the same AWS account. And even if the instances are private, they will still have the command executed. Now, this is fine, right? For hackers, at least. It's very powerful, it's very dangerous, and what I noticed is that it's a common misconfiguration that it's highly to be encountered. From the attacker's perspective, you need to have some requirements. So the instance you are targeting should be able to communicate with this service called SSM. You need to know the target instance ID, and you need to have this permission, SSM send command. And optionally, you need to have one of these permissions just if you are interested in getting the output of the command, but it's optional. Now, the instance ID, you can take it from the metadata API, that if you can query it, right? But you can also get it from any of these AWS CLI commands. There might be more. These are all that I discovered. Okay, let's start a scenario. Let's assume that we compromise a role or a user that has this permission. So we have SSM send command, SSM list command invocations for getting the output, and EC2 describe instances for retrieving the instances IDs. In terms of exploitation, you can do typical host exploitation stuff, like exfiltrating data, injecting backdoors, lateral movement, but you can also do cloud-specific attacks, mainly exfiltrating the access credentials from other EC2 instances. And this way, you can elevate your privileges even further. This is an example of how you can do that. You send a curl command to the instance metadata API. This will give you the name of the role attached to the instance. And then you perform another query where you add the name of the role and you will receive the access credentials of the instance's role. And this will basically give you the same level of privileges that the instance has. Can you get reversal through this feature? Yes, you can. And it's made in such a way that AWS images are like built for getting reversals. For example, Ubuntu images are not working that well with reversals, but Amazon images are just working out of the box with every payload I tried. This is an example of a payload that will give you a reversal. As you can see, nothing changed except the comment that we sent. And this comment is a classic remote reversal payload. This, again, will give us back a command ID, but now we are not interested in seeing the output, because the output, it will come in our shell, and as you can see, we are root. And I don't know about you, but when it was the last time when you got a reversal as root on an instance, only using such a simple payload? Good. There are some things that I would like to say now. The reversal from the internet will work only if the instance is public and if the security groups from the instance are allowing outbound connections to your host. However, you can get reversals without network connection, meaning that even if the instance is private, like it has no outbound connections, or even if the security group are not allowing outbound connections to your host, you can still get a reversal. And I built a tool for that. It's called EC2 step shell, essentially because it's a shell with 2 steps. You need to have SSM send command and one of these 2 permissions that will give you the output of the execution. It works both on Linux and Windows. It works both on private and public EC2 instances, again, even if you don't have network connectivity to it. And it doesn't trigger antiviruses from the way it works, because the request and the execution comes from a trusted AWS service and is not questioned by the antivirus. As a high-level overview, this is how it works. So basically, you send command to AWS Instance Manager, and in a loop, I keep trying to get the output from that command. And the AWS Instance Manager further communicates the command to the EC2 instance. So that's why you don't need network connectivity to it, because you're talking through a proxy. We'll see more of how the tool works in our demo. It has some basic features like OS detection, and as you can see, it looks like a shell, and the client will get a feeling that this is indeed critical because it's a reverse shell, it's not just a command execution. Now, let's add more restrictions. So EC2 step shell and everyone else are using 2 known documents for running system commands. And the documents are AWS run shell script and then the AWS run PowerShell script. But what if you encounter a policy that will not allow you to use exactly these 2 documents? So let's change a bit our permissions. We add a deny statement that will prevent us to use these 2 documents. And here comes a research I've did where I identified 7 other built-in documents that can be used to run system commands and can also be used to get reversals. Because of the time limitation, I will get into detail only on the last one, AWS run document, but I included the commands and some payloads in this presentation so that you can check them later. As you can see, the payloads are fairly simple. The AWS CLI command is fairly simple. By the way, I will leave you the link to my repository where I have these payloads, and there's also a link on securitycafe.ro where I detail this further. I will move through these slides until the last document. Yeah, sorry about that, but you can check them later. And now let's talk about a special document that I really like. It's called AWS Run Document. And this one downloads and executes documents from remote sources. And if we look at this permission, where we added all the documents or all the other documents that can execute code, it's basically useless if you didn't include the AWS Run document, because now I can make a copy of any of these documents and I can use AWS Run document to execute it. And I think it gives infinite possibilities, because defining your own documents, you can basically say, you can basically achieve whatever you want. This is an example of malicious document that I created. It takes some input parameters, the host and the port where you want to get the reversal. And in the main steps part, I have an action called AWS run shell script, which will execute that Python reverse shell payload. And essentially, you will get a reverse shell using this payload, and we'll see that in our demo. Cool. This command is a little bigger. However, if you're using my repository, you only need to care about the host and the port, because the payload will just work. And again, we are root, we got a reverse shell, and everything is fine. You can make your own malicious SSM documents. You have these actions that do a lot of things, like installing Windows applications, downloading files, installing PowerShell modules, and running system commands with run PowerShell script for Windows and run shell script for Linux. I made something that I called one document to rule them all, because it downloads and executes a file, and that's it. It works both on Windows and Linux. It takes as input the URL to download, the name of the file, and the destination where you want to save it. The first step is to download the file and save it where you want it to be saved. The next step is to run the file if the system is Windows, and the other step is to run the file if the system is Linux. And I think you can do whatever you want with this document. And this is the AWS CLI payload. I will leave a link at the end of the presentation with this repository, but I just wanted to show you that it exists. Cool. Let's dive into the demo. Cool. So just an introduction. In top left, we have the ngrok server that will forward the connections to our local host. In top right, we have the EC2 instances that we are targeting. As you can see, the first one is a public one because it has a public IP, and the second one is a private one because it doesn't have a public IP. In bottom right, we will get the reverse shells, and in the bottom left, we will run our payloads. Cool. So the first payload, we will get a reverse shell on the public instance by using AWS run shell script. As you can see, we immediately got a reverse shell, and we are root. Now, let's try the same payload, but for the private instance. So the same payload, but for the private instance, and There's no point in waiting. We will not get a reversal because the instance is private and can communicate outside its VPC. However, let's try to get a reversal with EC2 step shell on the private EC2 instance. And as you can see, we got something that looks like a reversal, works like a reversal, so it's a reversal. Of course, we are root, and you have some built-in commands in case the command you sent didn't execute, so you can try them manually later. Good. Now let's try some payloads using the other AWS documents. The first one being apply Ansible playbook, which will download an Ansible file and will execute it on the EC2 instance. This time we're targeting the public EC2 instance so that we can get a reversal. In the background, the file will be downloaded, executed, but as you can see, we got again a reversal. We can also see the file that was downloaded for getting a reversal, and we can also delete it, which is a problem for incident response, and we will talk about that immediately. Cool, and let's try another reversal payload, but this time using AWS run document. Again, against the public EC2 instance. This one is the Python reversal. Again, we are root. And yeah, it just works, and it's really simple, easy, at the same time powerful. Cool. Good. Bun, let's talk about being stealthy. I've configured my AWS account so that it has logging enabled at CloudTrail level, at VPC level. I've also enabled guard duty, AWS detective, and I wanted to see if something from AWS raises an alert that something like this happens. This right here is the run command dashboard where you can see the history of all the commands that were executed. And we'll see something interesting. Let's take the AWS run shell script, for example. We need to check the instance where the command was executed. As you can see, we have the output of the command. We also have some details about the instance, the input parameters, but it's missing something here. It's missing who actually executed this command. And this information is not present here. And we will see later where we can find this information. At the same time, let's check AWS run command, specifically because I want to show you that the document, the malicious document, is nowhere to be found in the AWS dashboard. We have, again, the input parameters, the result of the execution, but nothing about the document that was executed and who did it. Now, this is the VPC logging dashboard where you can enable a lot of things, but you can't actually see the content of the bytes, right? And you can't intercept the let me just pause for a second. We can't actually see the document that was downloaded. We have no way of knowing what was used with AWS run command. And previously, I showed you the S3 buckets that stored logs just to show you that indeed the logging was enabled. Now, regarding guard duty, which is a service for threat detection, the only alert that raised was that we performed an API call from Kali Linux, which I could have easily performed from Ubuntu or Windows, and this alert will not even be present. We have some information like who did it, IP, and so on, but nothing about the actual reversals and anything and everything that happened. Now, looking in CloudTrail, we will see something interesting. So here, we actually have the identity of the caller, the one that actually executed the command. We have the AWS access key, the IP, the username, but we're missing something from here. We're missing the input parameters. So as you can see, parameters are hidden due to security reasons, which makes sense. However, if you are doing an incident response and you are trying to get the full picture, now you have to look into AWS run command dashboard to check the input parameters, and you have to correlate that information with the API calls from CloudTrail just to know who did what. Now I'm looking for the run document API call, just to show you that the document that we downloaded, it's not here. And I didn't find any place in the AWS dashboard to actually see the document that was downloaded. So the question is, where is this document? Well, the answer is in the instance, which is a bit stupid. It's in a folder called var.log Amazon SSM, and it's in that file, Amazon SSM agent.log. And as you can see, only the root user can modify it. But guess who's the root user? Now we are checking this from the perspective of a defender, right? That legitimately connected to an EC2 instance. And let's look at this file, and let's identify the document that was downloaded. This contains a lot of information, very useful if you have the file. So this is actually the document. We have it, we can see it. We also have the input parameters, so this offers a much complete, a complete overview of what actually happened. And we can also see where the document was downloaded. And this is interesting because we will delete the document and we will leave basically no trace of what happened. Now, let's be the hacker one more time and let's connect back to the EC2 instance, running the same command with, running the same payload with AWS run command. And this time we'll do something that a pen tester, I think, should not do, but we will override the logs. Something that a real attacker can actually perform. Cool, so we got the reverse shell. Let's go to the logging directory. And because we are root and we can modify it, we will just write a cute message because we are at DefCamp and we are hackers. So something for the defenders to check, right? Cool. And let's do one more thing because the document is saved somewhere. Let's delete the document, and not only the document, but all the artifacts that were generated from our payloads and reverse shells. So each folder contains an artifact from our exploitation, and we will delete every folder. We will delete the folder, and that's it. So now there's no way of knowing what was the actual document. And I know that the document was downloaded from a repository, right? OK, so this is the defender's perspective. And that folder doesn't exist anymore. Yeah. And my question is the following. What would incident response say? Because I was saying that the GitHub was public and the file was downloaded from there, but I can delete the whole repository after I executed the payload. And I think the incident response will do just fine without this information. However, from AWS to make something, this is a design flaw, right? Because the logs are in a place where the vulnerability with that service can actually delete the logs. And I think AWS should provide more visibility into at least separate these things so that you can view the document and downloaded files in a separate place. Now let's talk about some common mistakes that I've noticed during the AWS Cloud Configuration reviews I've performed in the last years. Engineers are attaching Amazon SSM full access to an instance, and this will give every permission from SSM, and they are doing this because they want to manage the EC2 instance, and they are in a rush, right? And they think there's an issue with the permissions, and they will give the highest level of permissions from SSM just to be able to manage them. This policy also includes the permission to get the instance IDs, so you have all the requirements, and if you can compromise, and it's fairly easy, I've done this 3 times, you exfiltrate the access credentials from such an EC2 instance, and you basically compromised every other EC2 instance in the AWS account. And completely, I mean, because you are either root or anti-authority system. This is how the policy looks like. So you have described instance status, you have all the permissions from SSM, so sending commands and getting the output, and all of this is over all resources. Now, to defend against this, you need to deny at the organization level the execution of SSM documents, at least for computing services, like EC2 or AKS should not perform, should not use the SSM run command feature, right? Also, you should explicitly state what documents are permitted to run in your AWS organization and by who can be executed. Of course, less permission for EC2 instances. Amazon SSM managed instance core is a policy that is enough. You should put it on the instance and wait 15 minutes or 20 minutes, and the EC2 instance will be present in Fleet Manager and everything will be fine. Now, regarding leaks, we have the repository for EC2 step shell. We have the blog from my team, where me and my colleagues are writing research at securitycafe.ro. And we also have the repository with malicious documents, where you can find all the payloads I presented and much more. Thank you.